Having the data of the logged-in user, including the user's session, we can download the user's data from the server. In this case, we'll get the list of the to-do objects created for the given user. To do so, we'll test a couple of things we've already discussed. We'll use the async task to download data in the background. We'll use HTTP utils to get the data collection. And we'll parse it using a JSON array object, transforming it into appropriate model objects. As a result, we'll get a list of objects, which we'll later be able to display as a list. But first, let's focus on downloading data. We have to prepare the async task because we'll need to execute an HTTP query again. This time it will be called the moment we click refresh. That is the button we added to the action bar. We return to Android Studio, and in our to-do list activity, we add another option in the onOptionsItemSelected method. This time, we handle the refresh action. In this case, we'll call the async task, to which we don't have to pass any data because all data will be accessible from its level. That's why we can pass a void type as a parameter. It's a special type to which we can assign only a null. It's usually used to mark that we don't need parameters in a given place. We also won't inform about the progress, so let's use void. We return the to-do type list of objects. Right away, we can start our async task. Given that var args is actually an array, in an extreme case, we can provide 0 elements. That is, omit the parameter. The method will be called, and we'll be waiting for the list which we'll return. In order to get the data, first we need HTTP utils get to-dos. This is a method prepared especially in order to get data. If we look at the parse documentation, we see that in case of API REST, we can execute queries by directly providing the object name and the class name to be downloaded in the URL address. In our case, it's the to-do object. Obviously, we shouldn't forget about adding headers. If we didn't provide the session token here, we would receive objects visible to everyone. In our case, objects are assigned to the user at the moment of their creation. Because ACL has a specific value, which means that it's available only for the chosen user, by providing a session token, we introduce ourselves as the given user. We get a list of elements which are visible to us. We see such a call when we look inside HTTP utils. We want to select data in the form of a to-do class with the get method, and we pass our session token and get all the tasks which belong to us this way. Given that it's a get method, we don't pass any body. As a result, we get an object which includes a collection of our tasks. We will now call the method we referred to. we have to pass session token to it. As I've already shown you, it's available from the level of our login manager. For the time being, it's private, so we need to create a getter for it. With this method, we get a string which includes the result. The moment the result is obtained, we can log it to see what we've managed to get. We can test our application now. If we call the refresh option, in the logcat we'll see that we've obtained the result. We've got here, for instance, the result array. We can paste the obtained code into the JSON lint tool. Here we have the results array, which includes single elements, each of which looks similar. We have the content, the information about the task completion, the user who created the document, the date of creation, the date of the last update, the unique ID of the element, as well as the ACL. The access control list makes it necessary for us to pass the session. Otherwise, we won't be able to read the data. Only the current user may read the given element. Parsing such an object is pretty tedious. That's why we'll use the existing code attached to the module. It's a to-do Java class which we can paste to our project. In our case, an implementation of such a class already exists, so we can replace the code with the new one. Let us briefly discuss the implemented elements. It's very similar to the earlier implementation, but there are many more fields. Here, we'll find the content and done fields, which were there from the very beginning. Additionally, I've created the following fields: user ID, object ID, updated at, and created at. The keys which enable extracting data from a JSON object are also here in the form of constants. An additional issue is the date format, which enables parsing incoming strings to ordinary Java objects. In our case, the date will be stored as Java util date. We also have two methods. The first one, from JSON object, receives a JSON object, after which particular elements are mapped. That's why we create an empty to-do element, and that is where we'll set particular fields, extracting them from the JSON object. Everything is extracted in a standard way. The only peculiarity is using created at and updated at. Created at uses the created date format and parses the extracted string to a date. The only difference is that sometimes, in case of newly created objects, it may turn out that updated at is not set. If this is the case, we parse created at as updated at. Additionally, to gain access to the user ID, first we need to gain access to the user object. Not until this object do we call getString. As a result, we receive a fully filled in to-do. Now that we have the results collection, we also have a method which receives a JSON array and returns a to-do as a result. It's a method which iterates over JSON array and returns particular elements, adding them to the collection in order to eventually return the full collection. We'll discuss additional methods on the go, the moment we'll need them. For the time being, we need the two already discussed methods. Now we return to the place where we obtained the collection. After creating the result object, we save it as a JSON. If everything went all right, we can get our collection contained under the name results from the JSON object. The list we've got can be parsed using our to-do and the fromJSON method included in it. Now our method returns the element list. Given that each to-do can use the toString method, which displays the content and the done state, we can display these elements. After the download is finished, we can iterate over all the elements and display them in the onPostExecute method. Now we'll check our application. After clicking the refresh button, we see that it still executes our query. We also see the full collection of our objects, parsed and prepared for further processing. In the next module, we'll deal with displaying the obtained elements as a list with the use of adapters.